Hey everybody. Ooh, my goodness. Let's try that again. Hey everybody. We are going to go over concentrations of solutions. And this isn't when you just think really hard. This is when you measure really hard. Haha. All right, so it is really important if we talk about solutions that we talk about the concentration. And usually concentration, since it's such a long word, is just given the symbol of having these brackets. So if you're talking about the concentration of salt, it would be NaCl inside those closed-ended brackets, or the concentration of HCl, yada, yada, yada. Okay, it's a measurement of the amount of the solute in the given amount of solvent or the solution. And we'll get to that in a little bit. Obviously, this is important for any and all medical and scientific fields. If you don't have the right concentration of your medications or your treatments, or even something as simple as your saline solution, it can have dire consequences. We know what happens when we have um, hypotonic, or if we have hypertonic, or hopefully an isotonic solution. We don't want any of our body systems to get overwhelmed, especially when we're not feeling well. Okay, so there's lots of different ways to measure concentration. You can measure them by percent, you can measure them by mass, you can measure them by moles, percent by weight, percent by mass, all those different kinds. All right, so I like to show some examples of when my father was in the hospital. Couple of years before he passed away, he was severely hyponatremic, which means that he had low salt. NaCl, that's where the natrium, hyponatremic. So he would every once in a while lose his equilibrium. He would get really dizzy and stuff like that, and not be able to stand up because he didn't have enough of the salt in his body in order to function properly. So very important when we talk about our electrolytes, because I have seen what happens if somebody does not have the proper amount of electrolytes. So he would actually take salt tablets almost every day. And one of the things that happened is he ended up also having a really low potassium level. Okay, so KCl. And I took these pictures way back then, where it has a certain amount of, like, basically sugar and the sodium chloride, which is your NaCl. If they put the wrong concentrations in, it's not going to go well for the patient. Here you can say that these are the milli equivalents per 20 milliliters, and your total volumes are always going to be in milliliters. So if any of you are going to do anything with nursing or in the healthcare field, you need to be really comfortable with them. Okay, those units are extremely, extremely important to know. All right, so in general, what we end up having is two terms: dilute and concentrated. Okay, they are relative to one another. So this isn't a specific number. Okay, this right here, this is concentrated OJ. So can you drink this right out of the can? No. What do you need to do? You need to add water to it first. It's usually inside your pitcher here. Woo. Okay, you put your 1 can of your concentrated OJ, and then you usually put 2 to 3 cans of just water. Because dilute means that you have relatively little solute, and your concentrated means that you have plenty of the solute per solvent in there. And this is basically used in order to figure out what the difference is when you compare two systems. So remember when I showed you for my dad, you have your KCl? He needed to have a very dilute concentration of it, okay, in order to be happy and healthy. Because if he would have gotten a concentrated version, that would have been bad because it would have stopped his heart. It's actually what's used in some lethal injections to stop heart is too much potassium, and we don't want that to happen. Okay, so these concentrations are very important. All right, so what kinds of units are we going to use? There should be no surprise that we are going to use this word molarity. You've seen it all year, but not really talked about it that much specifically. So if you saw something that said 6 mHCl or 0.1 mHCl, that M stands for moles of solute per 1 liter of solution. And it is used as a conversion factor as well in order to figure out how many moles per liter you have of something, especially when you're doing some stoichiometry. So we can apply stoichiometry to this as well. Yeah, stoic's not going away. So like I said, it's the amount of solute per liters of solution. And it's important that you note that this says solution because a solution is a solute and a solvent together. All right, so which is more concentrated? Which is more dilute? Okay, 6M means I have 6 moles of HCl per 1 liter of solution, and zero point 0.1 molar is zero point 0.1 moles of HCl per 1 liter of solution. So who's the concentrated one? This one is. This is concentrated, and this one is dilute. Okay, so you have seen those numbers, you've seen those designations with the molarity, that's what it's meaning. So how do we make these different solutions? Okay, it's really important that you know how to prepare your own solutions when working in the lab. And one of the things that we do is we practice by figuring out how to make 1 molar solution of NaCl. So first, we need 1 mole of NaCl. So we look on the periodic table, 22.99 grams for Na, 35.45 grams for Cl, and I get my 58.44 grams. I weigh that out on my little scale. I add it to my special volumetric flask, which is hand etched with a line right there. Okay, and I am going to add, very importantly, enough deionized water to fill the flask. I have to add deionized water so it doesn't have any of the other ions in it, okay, because that would mess up the concentration. And I fill it with enough because this whole thing is the solution, okay? It didn't say add 1 liter of water, it says 1 liter of solution. Then we add enough water so that the bottom of the meniscus right here gets to that graduation mark on the volumetric flask. We add a stirring rod and we put it on the stir plate and we mix, mix, mix. Okay, so that's how we make a 1 molar solution. All right, so let's do a calculation. Let's figure out what our molarity is of our different um, substances. If you have 3.5 liters of a solution that contains 90.0 grams of sodium chloride, what is the molarity of that solution? Okay, so again, molarity is moles of solute per liters of solution. So we have 3.5 liters of the solution, so that goes in my denominator, and it contains 90 grams of sodium chloride. So I need to do a side calculation, 90.0 grams of NaCl, and on the previous slide we have the molar mass, which you can look up on the periodic table, because I need to get to moles. So I do the 58.44 grams of NaCl and 1 mole of NaCl on top. That is going to cancel out my units of grams. Go grab your calculators, push pause if you don't have it nearby, and then push play again. So we plug everything in and we get 1.54 moles of NaCl. This number goes up here. All right. Then what I do is I take my two values and I divide them. 1.54 moles divided by 3.50 liters gives us 0.44 molar NaCl. And I usually get into the habit of underlining the M My teacher, Mr. Ray, did that. I end up doing it as well, and it kind of differentiates between looking if that's like magnesium or just moles or mass or something like that. But if this number has 3 sig figs and this number has 3 sig figs, this number has 3 sig figs as well. All right, so this is all spelled out for those of you that have my notes. The 90 grams of NaCl, 1.54 moles of NaCl, then we do moles per liter, and then we get moles per liter to equal molar. And that is how we figure out molarity.